Hey everyone, today's video is going to be a quick little introduction to trigonometry. We're going to be talking about the three different trigonometric functions, which would be sine, cosine, and tangent, and how to find them. So this is going to be very basic, so beginner level trigonometry. So on the left over here, we have a triangle, and we've labeled an angle A. So the angle A is this angle. Next, you can also notice that we have a right angle, and then we have an angle over here, which we really don't know the size of. So the first thing you're going to want to do when you're looking at trigonometry is you're going to label the sides of your triangle. Now remember, all these functions will only work if it's a right triangle. A right triangle means that there's a right angle in the triangle. So there has to be a right angle for this for these three functions to work. You can't just do this on any normal triangle that doesn't have a right angle in it. So the first thing you're going to want to do is label the sides, as I said before. And to label the sides, you're basically just going to label them as opposite, adjacent, and hypotenuse. So you take your right angle, which is over here, and the side opposite to your right angle. So on the other end of your right angle will be your hypotenuse. So we're just going to write HYP. So it's your hypotenuse side. Next, you're going to take your angle A. The side opposite, again, the same thing. So the side opposite to angle A will be your opposite side. Pretty self-explanatory. Next, you're going to take angle A, as we have over here, and angle A has two sides leading from it. So we have this side, and we have this side. Now there's one more side you need to label in this triangle, and that's the adjacent side. As you can tell, we already have a hypotenuse over here. So the other side, that's not the hypotenuse, will be your adjacent side. So this is your adjacent side of the triangle. Why? Because it's sort of adjacent to angle A, which is over here, and it's not the hypotenuse. So the hypotenuse and the adjacent are different. You find the hypotenuse by finding the opposite of the right angle, and the adjacent side is the other side leading from angle A, and the opposite is the last side of the triangle. That's also one way to think about it. So on the right here, we have three different functions: sine, cosine, and tangent. I've already written down sine A is equal to opposite of hypotenuse, and so on and so forth, but I am going to go through this acronym we have over here. I'm not sure if it's an acronym or an abbreviation, but it's SO, CA, TOA. So we're going to go through this step by step. So we're going to go through SO, CA, and then TOA. So let's take SO, for example. What does this mean? SO basically means that the first term, which is sine, is equal to the opposite over the hypotenuse. So basically sine of any angle, so let's just put angle theta, for example, equals opposite over hypotenuse. And that's basically all that this means. It's sort of just an easy way for you to remember that sine is equal to the opposite the hypotenuse. So now we're going to go through the second one, which is cosine. So CA basically means the first term is cosine is equal to the adjacent over your hypotenuse. It's pretty self-explanatory. So cosine of any angle, let's say theta, is equal to the adjacent over the hypotenuse. We're going to go through our last one. I'm pretty sure you'll get the hang of it by now, but we're just going to go through the last sort of segment of that acronym, which is TOA. So TOA means the first term is tangent, because that's what we have at the beginning, and is equal to the opposite over the adjacent. And that's what I've written over here as well. Tangent is equal to the opposite over the adjacent side. Now you probably won't understand how to put this to use right now, but once we have an example, which we're going to do right now with like certain side lengths, then you'll understand how to do it. The question here says find sine, cosine, and tangent of angle A. If you look at the triangle over here on the left, they have angle A written out for us, and they've also noted the right angle, and they've also given us three side lengths. So 3, 4, and 5 are the lengths of the three sides of this triangle. So to find sine, cosine, and tangent, the first step you're going to do is label the sides, as I said before. To label the sides, take your right angle. Side opposite to that will be your hypotenuse. Instead of hypotenuse, I'm just going to put H. Take your angle A. The side opposite to that will be your opposite side. So I'm just going to put O. And then, as I said before, there's two sides leaning from angle A. This side over here and this side over here. We've already said that this side is equal to the hypotenuse. So that means that this side must be equal to A. So this is your adjacent side, 4. Now we're going to write each of our side lengths. Since this is the opposite side, we know that the opposite side has a length of 3 because that's the length that they've given us. Same thing goes for h has a length of 5 and a has a length of 4 because they've given us 5 and 4, and we know that those are the hypotenuse and adjacent sides. So now that we've written this down, we can write down our formulas or equations. So sine of a is equal to O over H. Why? You can see over here on the bottom left that I have SOHCAHTOA written, and the first term is so. So basically means that sine is equal to O over H, which is opposite over hypotenuse. Opposite over hypotenuse just means the side length, so 3 over 5, because the hypotenuse is equal to 5, and this would be your final value for the value of the sine of angle A. The same thing goes for cosine. It's pretty simple. Cosine A is equal to adjacent over hypotenuse. Again, why? Because C, which is over here, is cosine, is equal to A over H, as given by our SOHCAHTOA. So A has a value of 4, as we've already deducted from the triangle, and the hypotenuse is 5, as we did in the previous for sine. So our value for cosine is 4 over 5. We'll do one last formula, which is tangent. So tangent A is equal to O over A, because T is for tangent, and OA equals O over A. So tangent is equal to the opposite side over the adjacent side. Opposite is equal to 3, as we've already found out, and A is equal to 4. So our final value for the tangent of angle A is going to be 3 over 4. As you can see, all three of these values just use 3 numbers, 3, 4, and 5. They're just, placed in different places. So these would be your final answers for sine, cosine, and tangent of the triangle over here. Okay, so this is going to be our next example. We have a triangle here on the left with angle B mentioned, so we know this is angle B. We have this as a side length of 4, this as a side length of 1. They haven't given us the side length of the hypotenuse or the side that's remaining, and they've just given us that it's x. They've also given us a right angle. So that's all we've been given from the triangle, and they're asking to find sine, cosine, and tangent of angle B. Now this triangle looks very similar to our last example, except for the fact that we're using a different angle. In our last example, we were looking for angle A, but now we're looking for angle B. That's over here at the top right. So what do you want to do first? Now normally you would label the sides first, but we don't have the side lengths of each and every single side. We still don't have the side length of angle X. So now we're going to be using the Pythagorean Theorem. The Pythagorean Theorem, if you don't know it yet, I suggest you look up other videos to find out what the Pythagorean Theorem is and then come back to this video. But basically it's for when you have a right triangle. So this is your right triangle with the angle over here. This is A, B, and C. It basically states that A squared plus B squared is equal to C squared and allows you to find any one of these sides given two other sides. So that's what we're going to do with our triangle over here. We know that A squared plus B squared equals C squared. So A squared plus B squared equals C squared. We know we have one length, so we have 4, and we also have 1. We can use 4 as A or 4 as B, doesn't really matter. So we're going to do 1 squared plus 4 squared is equal to C squared because we don't know C, which is what we're trying to find over here. So 1 plus 16 is equal to C squared. Now to get rid of this squared over here on the right, we're going to take the square root of both sides. So we're going to take the square root of 1 plus 16, and this will equal C because you're canceling that sort of square on the right-hand side. So now we're going to simplify this. It's going to be the square root of 17 is equal to C. C is our remaining side over here, so we found that this is equal to the square root of 17. You don't need to simplify that to 2 decimal places just yet because it is easier to work with a radical rather than using decimals or anything. But for now, just leave it as square root of 17. Okay, so I've basically simplified what we found before and replaced the value of x as the square root of 17. So now we have all 3 sides of our triangle. Square root of 17, 4, and 1. Now we're going to start labeling our sides. Now we're going to do exactly what we did in our last example, and we're just going to label the sides. As I said last time, the first thing you're going to want to do is find your hypotenuse. We have our right angle over here, so the side opposite to that must be our hypotenuse, so we're going to label that H. Next, you're going to take angle B. In this case, angle B is at the top right, and the side opposite to that will be your opposite side. And then, as I said previously, we have 2 sides leading from angle B, this side and this side. One of them we've already labeled as our hypotenuse, so that means that the remaining one is our adjacent. So we found our 3 sides, the opposite, hypotenuse, and the adjacent side, and we're going to write down the side lengths. So A is equal to 4, as we have from over here. H is equal to the square root of 17, as you can tell from over here. and O is equal to 1, as you can tell from over here. So we've basically just written this down so it's easier to plug in our formulas. So now we're going to be finding the three different trigonometric values, sine, cosine, and tangent. So sine of this angle B is going to be equal to the opposite over the hypotenuse. Why? Because according to our SOHCAHTOA abbreviation or acronym kind of over here, we know that sine is equal to opposite over hypotenuse. So over h. O in this case is 1, and h is square root of 17. So 1 over square root of 17, and that would be your final value for sine. Next is cosine. Cosine of B is equal to A over h, so the adjacent over hypotenuse, because that's what we get from our SOHCAHTOA abbreviation. Cosine equals A over h. A in this triangle is equal to 4, and h is equal to square root of 17, so we have 4 over square root of 17. Same thing goes for tangent. Tangent B is equal to O over A, again showed by our SOHCAHTOA abbreviation over here. O is 1, and A is equal to 4, as you can tell from our triangle, so that would be your final value for tangent. Now, of course, you can simplify these values, so let's move it over to the right. So we have sine B is equal to 1 over square root of 17, And to simplify this, you can basically rationalize the denominator. So what you're going to be doing is multiplying by the denominator, or the square root that's on the denominator. In this case, you're going to do 1 times square root of 17 over square root of 17 into square root of 17. And that would simplify to the square root of 17 over 17. And that's just a simpler way of writing this if you don't want radicals in your denominator, or if they specify that you cannot have radicals in your denominator. For the 4 over root 17, we're just going to multiply the numerator by square root of 17 and the denominator by square root of 17. And this is just going to be equal to 4 root 17 over 17. So that would be your final value for cosine. This is for sine, and let's find our final value for tangent. As you can see, we have no radicals in the denominator, so it's just equal to 1 over 4, and that would be the final value that you give if asked. So this is how you find sine, cosine, and tangent of a given triangle. Even if the angles change, it still remains the same, so you're still going to use the same steps that I applied. You're just going to find the opposite of that angle instead. And I hope you guys understood this. Please comment down below any questions.